I'm excited because I see there is a technological shift happening in robotics right now, thanks to AI. Actually, VLM, vision language model, are evolving, and they can now control robots in an end-to-end fashion, connecting the video stream of the robot to the motors. And so you can discuss with them, and they can interact with the physical world in very incredible ways. So I'm going, before introducing LeRobot in more detail, I'm going to present a few videos of the state of the art in robotics. The video that was very mind-blowing for me was recently released by Physical Intelligence, and it shows a robot, a mobile robot, controlled end-to-end by a vision language action model. So just a slight improved version of a vision language model. And so it is trained by imitation learning. So it means that you kind of teleoperate the robot. So there is a human controlling the robot at first, annotating, recording some trajectories. So many trajectories are recorded of this kind of task, which is just taking care of the laundry. But then you train a model to just imitate the human, and you have a policy that can do this kind of task, which requires high precision, fast movements, and it gets smart because it compresses the information, and you can mess with the robots. It just successfully accomplished the task. And that's something that before was never seen in robotics. You have a lot of big robots. They are usually quite expensive, quite precise in manufacturing and so on, and they do repetitive tasks. But this time, they are able to be much more intelligent than before, and this can lead to a revolution, I think. Like socially and impact, have a very big impact worldwide. And not only it works for this robot, but because it is a very simple way to teach robots, it can be applied to more complex robots, actually any kind of robots. Here, this is the figure robots I mean, you have also the Tesla robots, you have the 1X robots, like now you have many robots in China, recently in UK, but this one, they showed recently a demo where it is controlled by a neural network. So these behaviors, they have been recorded by humans, but then the neural network is able to control autonomously the two robots. But those robots, yeah, so maybe let me show you a bit more in detail what the neural network, I mean, how they train it. Basically, they can, physical intelligence, they train it on a big data set of many form factor, many different robots, many tasks, and they just crush this data in a PaliGemma neural network. And they are trained to predict the next sequence of motor action. So it's like a motor, you can have angles, and you just predict the sequence of angles for each motor. So it cannot be more simple than that, basically. You don't have complex post-processing or those robots, they are actually, they cost quite a lot. You cannot I mean, it's very difficult to buy a humanoid right now. I think the cheapest from Unitree, if you buy it with hands, it costs like 60,000. And this technology, as I said, it can impact the world. And so we wanted to create this effort at Hugging Face, an open source effort, Apache 2, that contains all the tooling to reproduce what you've seen in the video. And we also build very affordable robots that you can assemble yourself. You can order the parts online. And we provide as well some tutorials. So the robots that we provide, they look like that. They are quite simple. You have the list of the parts. You can purchase them on Amazon. We have video of the assembly. It's like a bit more evolved than a Lego kit, but it's actually quite simple to assemble it. So here you have an example of recording the data, some trajectories of just a simple task, simple tall task like grasping Lego blocks. But we don't have a system that identify the Lego blocks, track it in the 3D space. No, it's just example of trajectory. You have the two cameras as inputs. It's actually the cell phone, your cell phone like iPhone or any kind of phone. You train it, and then you have the robot that can do it like totally autonomously. So we have all the tools like the dataset visualization, the dataset sharing on the hub. And the goal is that as a community, since we have access to this advanced tooling, we can just all benefit from it and yeah, and make more progress, enjoy all the benefit of open source, basically. So what we were also able to show is that with a simple setup with two arms, you can automate some shirt folding. So that's what you saw in a simple form, in a simpler form. That's what you saw at the beginning. But basically, it's possible to do it with now robots that cost $100 per arm instead of multiple thousands, like tens of thousands. And so this, again, it's using just the camera of my laptop, the camera of my iPhone. It's trained on my MacBook Pro. I recorded 50 to 100 trajectory. Of course, it's not perfect right now, but you can have, I would say, I didn't try much, but you can have like 60, 70% of success. And it's retrying when it's not when it's failing some sequence. Also, the benefit of building this community is that I get to meet incredible people, such as Rob from the Robot Studio, and with him we co-design this very cheap robot arm. And now it's available in all continents. Even if you don't have a 3D printer, you can order the parts. We have a list of providers. And then you can benefit, you can test the latest AI uploaded from the hub or from some GitHub of researchers and have an idea of the state of AI. Because think about it, LLM, you can access it through API or through a website, and directly you can have a sense of the state of what an AI is capable of. But for robotics, you really need to try it by yourself. Yeah, what's amazing is that there have been a lot of different people improving the arm, trying different things. On the bottom left, you can see the arm. It is plugged on a Muppet connected to ChatGPT, and basically it's a kind of persona that a chief that helps you cook and and a kind of animatronics. I mean, people they build awesome things on top of this technology. So it's just a few examples. There are a ton of videos on our Discord of people like automating a random task, like a pistachio sorter. Sometimes you have some pistachio that are closed, some that are open. You want to sort. We do some worldwide hackathon as well. So we organized one a few months ago, and there have been a lot of people without a robotic background, and I think that's very important. So we are going to organize some hackathon in a yeah, we'll try to organize them at a higher frequency. But there are also some efforts, some people independently, they organize hackathon in China, soon in New York, etc. So really advise you to join our Discord to get to know those opportunities to learn with the people. And also, we recently collaborated with some students from University of Illinois, especially the SIG Robotics Lab, to co-design this mobile manipulator, an affordable one. We call it LeKiwi because it's Kiwi Drive. It's a very funny way. Like you have three wheels. Of course, it's to cut the cost, but it can rotate anywhere and it's quite accurate in its movement. You have the battery, you have a Raspberry Pi, you can connect it to your laptop, and basically you first also remote control it to record some trajectory, then you train a neural network, and then the neural network, the VLA, control this robot autonomously. It's like an upgraded self-driving car, but for your home. And I think it can open a lot of opportunities, a lot of tasks to automate with this. Also, we are able to show that we can also control high-end robots, like the one from Poland Robotics, which is a French startup. Unitree also, which is quite known in China and over the world, actually, they also used our code to automate some manipulation task. I'm so glad, like our effort is quite young and still people really love it and use it around the world. So it's really amazing. So yeah, in this video, yeah, I mean, you can see that the dog was really impressed by the autonomous behavior of the robot. But yeah, basically we were showing that we can ask it to take manipulate objects. It was very just a proof of concept. It's the only type of behavior it can do in sequence, but we can show that end to end we can also control the rotation of every motors, including the wheels and so on, and have some kind of human interaction. Robotics now it's all about humanoid. In the videos that are the crazy videos that were have been released in the past days, and we are also working on a humanoid, totally open source again, with some very affordable technology, some nice tricks that are actually very capable, very good. So this arm and hand, it's 5 fingers. You can control a lot of degree of freedom, and we co-design it with this glove that you see, the white. Now we have the full arm that Martino is designing. And so it's our teleoperation device. So that's again the first step. It's to be able to teleoperate it, to record trajectories, and then you train on those trajectories. And this glove, it's like also 3D printed. It has very cheap sensor, and so it's under $50. So the whole setup it's 500. And term of capabilities, it is really, really high end, I would say. You don't see a lot of dexterous hand like this, and especially not at 500. I was looking on Twitter. There is one, just the hand. I'm not even sure it has this degree of freedom, and it costs 16,000, and it's like very cheap in comparison. I mean, in comparison to the other type of hands. The goal is to build, of course, a full humanoid with the legs and the head. So we are working on it. So we also try to design the reinforcement learning stack to make it work. It's a work in progress. So yeah, I mean, if you're interested, don't hesitate. Look at our GitHub, Hugging Face LeRobot. You can also follow me on Blue Sky and Twitter for the latest updates. And especially don't hesitate to ask questions on our Discord.
So there's a question, are the models LeRobot trains pre-trained?
I mean, we have some checkpoints. They are on the hub. So in the tutorial, for instance, you can use our pre-trained model in simulation. That's the first contact that you can have with the library. You don't have, I mean, your robot is not yet arrived. And so you can download this pre-trained model, evaluate it, and you can see that it can push some T-shape object. Of course, we want to go to very good, high quality, real world pre-trained models that you can run on a simple laptop. It's work in progress. Recently, we ported the physical intelligence, like the Pi0 base model. So the one, some version that you saw at the beginning of the video that automate the laundry. But I would say it was not trained on our affordable robots, so it doesn't transfer very well. It's just the beginning. I think it's the first big foundation model that we port, and I'm sure that over the next months there will be a very big improvement, and hopefully, I mean, I'm pretty convinced that all those labs, they see the opportunity to not only have an impact on the research community, but to have an impact on open source community worldwide.
Follow-up question from the same person. What is the minimum number of trajectories to get something that kind of work? Is it robust to camera position changes?
It's an iterative process. It really depends on the robustness that you need, the difficulty of the task. For instance, to grasp Lego blocks at a few different places with 50 trajectory, we were able to get 100% success. Of course, if you start changing the orientation of the camera, or you train during the day and you want to test during the night, of course, then the success rate we get low. So yeah, we are really looking forward to training with the community on all the data recorded by the community and all the open source datasets already available. We want to train those big pre-trained models and that are quite a bit more robust to camera viewpoint, to perturbation, and so on, that have been trained with data augmentation and so on, and to use them as a base for fine-tuning on your task. And it has been shown that this really helps in various research papers on bigger robots. So it will happen in this year, I think.
Any timeline for the launch of the humanoid LeRobot? When is it expected to be released?
I'm quite optimistic. Yeah, I'm an optimist. So I would say 3 months. We will see. What's sure is that we are going to release the arm and the hands in a few weeks, like very soon, with the whole glove. And when we release it, it will be very simple to assemble. Yeah, that's we want to make it. That's why we iterate a bit on it. We really want to reach a high quality, and also we develop the software with the hardware, so it allows us to really push the limits of what is possible currently with very affordable motors and so on. So it takes a bit of time because we are developing a lot, but the impact will be very important, I think. So
you are developing hardware in Paris, right?
We are able to collaborate with a lot of people worldwide. For instance, LeKiwi, it is the result of a collaboration with some students from Illinois, so university, so the US. But yeah, Rob, he is close to the French border, and we have a whole floor at Hugging Face in Paris where we work on hardware.
You're optimizing the software to work on that hardware, right?
Yeah.
And that sort of increases the performance.
Yeah, and we use Python. So yeah, originally in robotics, the stack was quite complex because you had to know, I mean, ROS, for instance, which is quite advanced in terms of robotics. You had to know all about inverse kinematic, a lot of control theory for your robots because you were controlling the robots in a simpler 3D space. But in our case, we simplified this. We just control the robot, the motor's angles, and also there was this stack about this vision stack where you had to learn all using depth cameras and yeah, detecting the objects, detecting the type of grasp that you wanted to achieve, optimizing the trajectory. And well, yeah, we really simplified everything. And so now, I mean, we are just using Python and PyTorch, basically,
Mm, that's cool.
even to communicate to the motors.
I mean, you're truly democratizing this.
With, I think, 1 year, like 2 years ago, it would have been very difficult to do it. But with this new technology, I think we started just at the right time.
What you're referring, so what shift has happened that allowed to transfer this to Python and PyTorch and make it like really easy, much easier to like build on top of it?
Yeah, so there was a breakthrough in imitation learning that like it was very not clear that you could just record some trajectories, like not a lot of trajectories, train a neural network just to imitate those human trajectory, and then to get a robot that perform much better than before. It was really not obvious. A lot of people were thinking about simulation, about reinforcement learning on many robots. There were a lot on expensive robots and so on. But with this simple technique, you could do it even on affordable robots. So that was the breakthrough. I think really this, I mean, a lot of researchers, I mean, it emerged at various places, but for me, the paper that was really very impactful was Aloha by Tony Zhao at Stanford. And I was quite lucky because I was working with him at Tesla on self-driving. So it was very inspiring, his work at Stanford. And so after that, I was able, yeah, to transfer all my knowledge in AI to robotics, to bigger robots. Igor, I really like the work that you're doing. I follow you. And you are saying like what GPU will be needed to run Pi0 model when it will be ported to LeRobot. So actually, we already ported Pi0. For now, it requires a big RTX. Some people from the community could try to quantize it and so on, so that you can run it on a smaller GPU. But yeah, I think it's really the beginning. Physical intelligence, it's yeah, they optimize their model to run on a quite expensive GPU. So that's the current state of things. And then there will be Pi0 fast as well, which I think requires maybe a bit less memory. I'm not sure. But I mean, eventually there will be some quite compressed foundational model for robotics. What are the biggest challenges of working with cheaper robotics hardware? I mean, first, it's like uncharted territory, because most of the research, most of the industry is focused on high-end motors. But for us, we are really focused on making it accessible and on data, on collecting data as a community. So we want them to be very, very accessible. Of course, sometimes the hardware is a bit the quality, the precision is not is not of so for instance, if you try to walk when you have some powerful and high-end motors, it's easier because you have a very small noise. But when your motors are cheap, sometimes you can have a bit of mismatch of noise. When you when you give power to the robots, it's not perfect. So there are some little quirks that are more difficult to model. But I think that the approach that we are taking with AI, it's general enough that it can manage with this cheap hardware. It's like us when we walk, our body is always changing, we get hurt, we can still adapt our walk. And yeah, so that's why I think even though it's uncharted territory, I think it's quite promising all the results that we were able to get, and we'll continue to push this. Do you foresee we'll need very good network communication soon and maybe even high-speed local server connection? I see a future where we'll have a lot of robots everywhere, and of course they will communicate between each other through localized nodes on the cloud, I think. And so when you will be able to teach to one robot to do a task, it will benefit to all the robots. So of course there will be this question of network communication. Maybe you don't want to train everything on the robot, but maybe you can push the data and train in the cloud. I think that yeah, there will be a lot of opportunity for fleet learning, like Tesla.
Follow-up question from Michael that we missed. Where do you see the best return of investment more? Better motors, sensors, more compute?
For me, it's just the data. Investing a lot of time in an approach using reinforcement learning, it allows to train the robot while you are recording the data. So you start teleoperating the robot, and then you give it, and the policy, the model is training on the data you're recording, and then it take over, and you can show it when it's failing. You can correct its trajectory and so on. But like you really you're training your policy at the same time as you are recording data, and this we think it will be the best way to record the highest quality data, the data where at time t the policy fails, and you are always on the edge of the capability of the policy. Yeah, so for me it's like data is the key, and we need to develop all the stack to go there. And the sensors like RGB, it's enough. Audio, it's I think enough for touch for a lot of tasks. And yeah.
Just a follow-up question from me, like speaking of data, it's really hard to gather right data for training. So my question is, like, is imitation learning like one of the ways to collect high quality data? Like what are the other ways to collect like to bring the diversity of data needed for robotics?
I mean, for me, it's like community effort. We also don't know what are the tasks that we want to automate. We have all those ideas from science fiction with I don't know, Star Wars, R2D2, the way we communicate with robots and so on. In practice, it's difficult to know what are the first tasks that we want to automate, maybe laundry or things like that. And then yeah, for me, it's the diversity, like to get the right data. It's always when the policy fails. That's when you know that the space of the data, yeah, is not covered, and that's where you need to put your effort. It's always an iteration process. I think it's you can always you can guess that some data is lacking and you need more diversity. It has been shown experimentally that more diverse data is helping for robotics. But yeah, I think the only way is you try it on the robot, you see it fails, and then you record more data.